Modeling with quadratic functions. This is the last lesson of topic C. You have a test coming up perhaps on Wednesday. Here is the opening exercise. Draw as many quadratic graphs as possible through the following 2 points on the graph. Your neighbor will be me because we're going to do this together. These points are 0, 4, and 1, 9. Those points are right here and right here. Describe to me a quadratic graph that you could draw that includes those 2 points. You could draw one like this. I think he's talking about if you did a curve somewhere about here, you could put one in like that. How else could I put a quadratic graph on here? You could make one upside down. You could go like this through there. You need 2 points to make a straight line. You can make a quadratic graph with only 2 points, but look at how many options you have. You have 2 there, and you could do more than that. You need at least 3 points to make a quadratic graph. We're going to use the example with the blue points 0, 4, 1, 9, and now we're going to put in negative 3, 1 from above to write the equation for the quadratic that contains the 3 points. There are your 3 points. We have to figure out what the equation is of the quadratic graph that contains those 3 points. This is no different than when we did straight lines and you were given 2 points. You had to find the slope, put the slope into the y or the slope-intercept form, solve for the y-intercept after plugging in 2 points, and then come up with the equation. For this one, you're going to do something similar, except you're going to have this. Y equals ax squared plus bx plus c. We've used that numerous times. First, we have to figure out what the y-intercept would be. Which letter on there represents the y-intercept? C represents the y-intercept. So we could redo this with y equals ax squared plus bx and then plus 4 from the y-intercept there. If I plug in 0 for x here and here, they would cancel out and you're left with just 4. So essentially that would be putting in 0 and coming back with 4. So I would put in 0, square it, put in 0 here times b, and just have a c there. These cancel out. These cancel out, these cancel out. That's how we get c equals 4. That's the first piece we need for the quadratic function. Next up, we have to figure out what a and b are. So we're going to go back And we're going to start with this. Y equals ax squared plus bx, and we know that c is 4. We're going to use one of these points. We're going to use 1, 9 to start with. So this is for 0.19. That means if I plug in a 1 to this function for x, I will come back with a 9 for y. So we put 9 in for y. And we put 1 in for x. We have to simplify this as best as we can. So we have 9 equals a times 1 squared is simply a. B times 1 is b. And then we have plus 4. We want to move this away from the a and the b and put it on the left side. So it changes signs to minus 4. And we end up with a 5 equals a plus b. We want to hold that equation. And we're going to come back to it after we take care of the other point. The other point is negative 3, 1. Negative 3 and then a 1. So again, we're going to start with y equals ax squared plus bx and plus 4. If we put in a negative 3 into this function for x, we will come back with a 1 for the y. Put in your negative 3 for the x. And then simplify. The quantity squared of negative 3, that's been a quiz question. What is the quantity squared of negative 3? It is not negative 9. It's positive 9. 9a, and then we have negative 3 times b, so that is minus 3b. We want to move that 4 over to the left-hand side. It becomes minus 4, and then we simplify it. 1 minus 4 is negative 3. Now we have a second equation here. We have two equations we need to recopy. And we're going to move those over to a second piece of paper. There's the second piece of paper I need. And we're going to reverse the order of these equations. Instead of 5 equals a plus b, we're going to do a plus b equals 5. So up here I put a plus b equals 5. And then the second one was 9a minus 3b equals negative 3. 9a minus 3b equals negative 3. From before, we learned that we can solve this by elimination. If you're going to solve it by elimination, you want these two items here to have the same number out to the left. We already have a 9 on one of them, so we're going to multiply the top one by 9. We will get 9a plus 9b equals 45. The bottom one stays the same. Since you have the same item here with the exact same sign, positive, then you can subtract these two. 9a minus 9a cancels out. Nothing is left. But then you have 9b minus a negative 3b. That is 12b. 45 minus a negative 3 is 48. So to solve, we divide 48 by 12 and come up with a positive 4. And last we have to solve for a. So we go all the way back to the top and we use a plus b equals 5. And we know that b is 4. So put 4 in for b. And then solve this equation. Move the 4 to the right, change the sign. 5 minus 4 is 1. For the function, it must be in this form: y equals ax squared plus bx plus c. Plug in all the values that we found throughout this problem. The y stays the way it is. It's a function, so we start with y equals. The a value is 1, so we just have an x squared. The b value is 4, so we have plus 4x, and we found c to be 4, so that is plus 4. Here is the function that represents the 3 points through which the quadratic function will travel when graphed.